tells you where your roots are. Okay, they have the locations of them. Nature of roots today. Nature of roots, we're just going to talk about how many. Or not. We're not going to talk about anything. All right, so quadratic formula tells you the location. And like I said, you can do, when you're finding your x-intercepts, you can use the quadratic formula instead of factoring every time. It will work. So if factoring's not your jam, and you're committed to doing things a little bit longer, then the quadratic formula is where that. Sometimes you can only use the quadratic formula, but you can use it always if you're solving. If I ask you to factor, then you gotta actually factor, okay? But if you're solving for x-intercepts, you can use the quadratic formula. So we're talking about how many roots today, and we're not actually like figuring out where they are on the graph. All right, so here's the thing. We just had this happen over here with this question. It doesn't matter if you add 0 or take away 0. It has no bearing on that negative 8, right? Guys agree with me? And how many roots did I have? When we talk about roots, roots are x-intercepts. What else do we call them? Roots, x-intercepts, and zeros. And zeros of the function. Brilliant. Okay, I'm glad you guys are around. So how many did we have? 1, because we didn't add or subtract anything. So you just figured that out. So if it's a 0, you have 1 root. So what we're looking at today is just what's under the root sign. This is called your discriminant. So it's inside the quadratic formula. I will never give you the discriminant quote-unquote formula because it's inside your quadratic formula. This is just to help you decide, just kind of like visualizing when we first started in chapter 3. This is going to help you figure out how many roots you have. So we know that if it's a 0, just like that one, we're going to have 1 root. If it's a positive number, it doesn't matter if it's root 5, it's root 297, if it's a positive number, you're going to end up with 2 answers with 2 roots. And if the thing under the square root tends to be a negative, or shows up as a negative, you get -4 into there, can you take the square root of a negative number? No. So all of a sudden, you have no roots. And we know that that's possible. We know that a graph has a vertex above the x-axis. It opens up. There's no roots. So you got to be careful of this one. If you get a negative under here, you have to state no roots. Remember back in grade 10, there's some stuff that's unfactorable. You couldn't leave a blank and had to write unfactorable next to it. So same thing here. You have to say no roots, no x-intercepts, whatever you want to say. But you have to say something. Okay, so if you were asked how many roots, just deal with the information that you need. So you're going to deal with the stuff under the root sign. If you solve for the actual, like, where the x-intercepts are located, you can, and you'll get the right answer. I won't be looking, you'll have to say like 2 roots, like if it actually works out, but it's extra work. So what you're looking at is what's under the root sign. So that's the b squared minus 4. It's going to be a tough day, I think. AC. Okay, so that's what's under the root sign. That's all I care about when I'm asking how many roots. Okay. So we may ask it to you in a weird way. Describe the nature of the roots. Describe the nature of the roots just means how many. Okay. I don't know why we just don't ask it to you in study language. What do I know how many? All right. So you mathematical wizards. How many? Where do you start? Everybody knows where ABC is, right? Like your A is out here, your B is the coefficient here, and your C is the constant. Everybody knows that? Of course you do. You didn't, you know now. So we're going to have -6 squared minus 4 times 1, because there's an invisible coefficient on the x squared, times 7. So I have 36 minus 28. So that's going to leave me with a positive 8. Is this a positive number? Yes. So, and again, make sure you're answering the question. You can't just leave it as a positive 8 and think that I'm going to make a legal case for you. You have to tell me. This is nice and easy. Sometimes I don't even do the math. I just know that 36 is bigger than 28, right? So I'm going to end up with a positive number here. I might just write down positive and then 2 roots. Like if I've got 739 minus 68, something that's not like, I'm not doing it quick, and the first number is bigger, and the second number is smaller, and the answer is going to be a positive number. I'm just going to write down positive, and I'm going to say 2 roots. Right? It's about becoming more efficient in what we're doing, but some of you might not be comfortable with that yet. I learned that in my calc class. I do ish math, I do like approximate math, and just as I'm working towards infinities, and the students don't like that because they're not concrete numbers. So if you don't like it, always calculate it. Okay, pretty easy, right? Okay, this will be on your test, on your quiz, and on your exam. What you will look at it. It'll be on your test, your quiz, and the exam. Okay, so this gives me some information. It has 2 real roots, and I need some values of m to make that possible. We know there's not one correct answer. What do we know that the discriminant has to be if it has 2 real roots? It has to be a positive. So I'm going to make a statement. You guys are not going to like the statement. This takes you back to grade 9. Maybe you'll like it. Maybe you'll be fine. How do I say that this is least squared to be greater than? You're really not fun. If I want to say that this is positive, there's lots of positives. It can be positive 10, it can be positive 1,000, right? There's lots of positives. All I care about, I don't care about how much the number is. I just care that it's bigger than 0. You guys remember that from grade 9? Right? So what this says is what's on the left-hand side. The alligator is pointing towards it, so this is the bigger part. This is the smaller part. You guys with me so far? Yes? Okay, so we are going to substitute what we know. We know B is 8 squared, 4 times 1 times m is greater than 0. Oh my goodness. So I get 64 minus 4m is greater than 0. So this is grade 9. This is grade 9. You gotta dig back into those notes that you burned in summer of grade 9. All right, so I need to treat it just like an equation. I got to solve for the letter m. Okay, so what do you want to do? You want to bring the 64 over? Okay, so I'm left with a negative 4m here, greater than, no. All right, greater than a negative 64. Everybody with me? How about m by itself? Divide by negative 4. Do you guys remember the secret rule for inequalities? So when I divide by a negative coefficient, it switches the sign. You guys remember that? Okay, it's kind of important. If it was a positive coefficient, it stays the same. What's 64 divided by 4? It's like not 8. 16? And it's a positive 16, right? Yep. So we know that m can be any value less and 16. The 16, the alligator mouth is pointing to, so that's the biggest number. Everything to the right of it's going to be less than. So I can put in 15.9 and it works. I can put in negative 3.2 and it works. But as soon as I put in 16.5 or 17, it doesn't work. Or 16.0001, it doesn't work. So the M value has to be less than 16. So this is your grade 9 rule. Did you guys write down the secret rule? I love it. We got secret formulas, secret rules, things you need to know. If you divide by a positive coefficient in inequality, inequality stays the same. If you divide by a negative coefficient, it flips. It only applies to negative coefficient. Hint, hint, nudge, nudge. This will be on your quiz, your test, and your exam. I love that. I love the excitement I'm feeling. Now, that doesn't mean that there is an x-intercept everywhere less than 16. That just means that M has to have a value of less than 16 in order to have two roots on the graph if I were to graph it. Because we're talking about how many, we're not talking about where. Okay, so describe the nature of the roots for this one. What am I going to do? What's step 1? Move everything. We want to move everything to the left-hand side. Could you move everything to the right-hand side? Technically, yes. Doesn't matter, right? You just have a negative A value and you have a positive B value. Like, it doesn't matter. It'll work out to wash. So it doesn't matter what side you move it to. And as you work with algebra and as you become super comfortable with it, I'm fine with the variable on either side. Some people are really strict. They want the variable just on the left. But I can read it either way. If you are not to that point, no shame in that game. Keep your variables on your left-hand side. Okay, so I want to describe the nature of roots. I don't want to know where they are. I just want to know how many I have. So my discriminant, I'm going to have negative 5 squared times 4 times A times C. Notice I have no equal signs here. So at no point am I going to put an equal sign in. That's 12 times 9. That's what the one away. Yes, you're right. Okay, so do I need to do the math here? Like, do I actually need to figure out what the number is? No. What do we know about the number though? It's definitely going to be a negative. So how many roots? Yeah. No, not impossible. Just means that it's never going to touch the x-axis. Right? We're still going to have a graph. We're still going to be able to graph it, no problem at all. It just means that it's not going to touch the x-axis. Okay, not terrible. Not terrible. Now, can I go back up to this question for a second? What if this question asked, same equation, but instead of having 2 real roots, now it says no roots? What would change in how I tackle this? Yes. So this is what's gonna happen to this? Right, because we know that the discriminant has to be less than 0 now, right? So this had to be greater when I have 2 roots. If I have no roots, we know that this should be a negative value, right? So my sign changes and do exactly the same thing. Guess what? I get the exact same numbers. But what do you think happens to the sign? It would flip, right? That's it. It's not rocket science, but people have a really hard time kind of visualizing this one because we go back to inequalities from grade 9 and you didn't touch them at all in grade 10. Did you touch them in grade 10? I don't think we do them at all in grade 10. So you talk about them, you put them on a number line in grade 9, life's good, and then you don't talk about them in grade 10 and in grade 11. I expect you to know everything about them. Seems fair.
So